Ashton, and here's my poster on protein synthesis. So basically, DNA changes to RNA and ends up changing to a protein or some other kind of polypeptide or amino acid. And the way it does that is first through transcription and then through translation. And so over here, it gets kind of complicated. You first have your DNA, which kind of color-coded. So your red, your DNA is in your nucleus. All the transcription happens inside the nucleus. Your C's will turn to G's, your G's turn to C's, your T's will turn to A's, your A should turn to A should turn to T, but there's no T in mRNA, which means your A's turn to U's, and so forth. And then after this transcription happens and the DNA turns to RNA, your RNA will go through the cytoplasm and find a ribosome to attach to. Once it attaches in there, inside the ribosome, your mRNA then gets translated once again into what is called your tRNA. And so the same process happens. Your T's turn to A's, your A's turn to U's, C's to G, G to C, and so forth. They do happen in threes. So your threes will attach and they form an anticodon hookup, basically. Once all of these threes get together, which there could be 4 or there could be 2 million. That's just the way proteins work. They get complicated. But those form a polypeptide chain. Once this chain is formed, it moves in, the ribosome and all will move into what is called the rough ER. Inside the rough ER, this polypeptide chain or protein or amino acid, however you want to put it, will then get modified into a new 3D shape. And once it's modified in there, it has to be inside a vessel. It can't just go freely because that's just not the way it works. So it gets put in the vessel and then it moves to the Golgi apparatus. Inside your Golgi apparatus, it is once again then read and interpreted to say, hey, this needs to go outside the cell, which would be exocytosis. So in your exocytosis, it then says, okay, let's go. They hop in this other little vessel and say do-do-do, and it moves outside the cell and into the bloodstream or wherever that protein, amino acid, polypeptide chain, whatever fancy word you want to put for it, needs to go.